Imagine for a moment that you're standing on a vast, seemingly unshakable ground. You look up, and the sky stretches endlessly above, the sun shining brightly, life bustling all around. But what if I told you that deep beneath your feet, far below the surface, lies a hidden world that holds the key to all of this? This world is the Earth's core, a fiery, dynamic engine that not only keeps our planet alive but also shields us from the harsh realities of space. In today's episode of Zane Facts Channel, we're diving deep into the Earth's core to uncover why it's not just a fiery ball of iron, but the lifeblood of our planet. The heartbeat of the planet. The Earth's core, located about 1,800 miles beneath our feet, is split into two main parts, the outer core and the inner core. The outer core is a swirling sea of molten iron and nickel, while the inner core is a solid ball composed mostly of iron. But this is not just a simple lump of metal. It's a pulsating heart, generating the magnetic field that protects all life on Earth. Interesting facts. The inner core grows about a millimeter each year as the Earth cools. But what's fascinating is that it doesn't grow evenly. One side of the core beneath Indonesia is expanding faster than the other. This lopsided growth is still a mystery to scientists, but it's believed to play a crucial role in maintaining the stability of our planet's magnetic field. Without the core, Earth would lose its magnetic field, leaving us exposed to deadly solar winds that could strip away our atmosphere, much like what happened to Mars. The geodynamo, Earth's invisible shield. The movement of the molten iron in the outer core creates what is known as the geodynamo, responsible for generating Earth's magnetic field. This invisible shield extends far into space and deflects harmful solar radiation, preventing it from reaching the surface. It's this very shield that makes Earth habitable, protecting our atmosphere and allowing life to flourish. Interesting facts. The Earth's magnetic field is not static. It has flipped many times throughout history. In fact, we are currently overdue for a magnetic reversal where the North and South poles switch places. During this reversal, the magnetic field weakens, which could expose us to higher levels of radiation. The geodynamo is incredibly powerful, but it's also influenced by factors far above it, like the movement of tectonic plates and even the cooling of the Earth's surface. A core under pressure. The inner core of the Earth is under immense pressure, literally. With temperatures soaring above 9,000 degrees Fahrenheit, or 4,982 degrees Celsius, the core remains solid due to the extreme pressure from the layers above. This pressure is so intense that it keeps the iron in the core from melting despite the scorching temperatures. Interesting facts. The pressure at the Earth's core is over 3 million times the atmospheric pressure at the surface. This is why the inner core, despite being so hot, is solid. Seismic waves generated by earthquakes travel faster through the core between the North and South poles than across the equator. This indicates that the iron crystals in the inner core are aligned in a specific pattern, likely due to the lopsided growth of the core. The Earth's core doesn't just influence the magnetic field, it also affects the planet's geological activity. The heat from the core drives the movement of tectonic plates, leading to the creation of mountains, earthquakes, and volcanic eruptions. These processes are essential for recycling carbon and other elements necessary for life. Interesting facts. The heat driving this tectonic activity is partly residual heat from the formation of the Earth, but also from radioactive decay of elements like uranium and thorium within the mantle. The Earth's core plays a crucial role in the carbon cycle. Volcanic eruptions driven by the movement of tectonic plates release carbon dioxide into the atmosphere, which is essential for maintaining the greenhouse effect that keeps our planet warm. While the Earth's core has remained relatively stable for billions of years, it is constantly evolving. As the planet cools, the inner core will continue to grow, and one day the outer core may solidify entirely. When this happens, the geodynamo will cease and the magnetic field could disappear, drastically changing life on Earth. Interesting facts. If the Earth's core were to stop spinning, the planet's magnetic field would collapse, potentially leading to a scenario similar to Mars, where the atmosphere was stripped away, leaving a barren, lifeless surface. Scientists believe that studying the core can provide insights into the future of our planet and the potential habitability of other planets. Even with all the knowledge we've gathered, the Earth's core remains one of the least understood parts of our planet. One of the biggest mysteries is the nature of the boundary between the outer and inner core, known as the Lehmann discontinuity. This boundary, named after Danish seismologist Inge Lehmann, who discovered it in 1936, is where seismic waves abruptly change speed. The reasons behind this change are still not fully understood, raising questions about what exactly is happening at this critical boundary. Interesting fact: seismologists have discovered that the Earth's inner core is not just a simple solid iron sphere. Recent studies suggest that it may have its own inner core, a solid iron heart within the heart. This innermost core could be composed of a different crystalline structure than the outer part of the inner core, adding another layer of complexity to our understanding of the Earth's interior. The Lehmann discontinuity isn't uniform. It varies in depth depending on where you are on the planet. This variation suggests that the inner core might not be perfectly spherical and could have irregularities or anisotropies that affect how seismic waves travel through it. The Earth's core also has an indirect yet significant impact on climate change. The magnetic field generated by the core influences the Earth's atmosphere and weather patterns. For example, geomagnetic storms, disturbances in the Earth's magnetic field caused by solar wind, can disrupt weather systems and even influence climate over long periods. Geomagnetic storms can induce currents in the Earth's surface, affecting power grids and causing widespread blackouts. The most famous of these, the Carrington event in 1859, caused telegraph systems to fail across Europe and North America. If such an event happened today, it could have devastating effects on our modern technological infrastructure. The movement of the Earth's core and its influence on the magnetic field also affects the migration patterns of animals, particularly birds and sea turtles, who rely on the magnetic field to navigate. As the magnetic poles shift, these species must adapt to new migratory routes, which can have profound impacts on ecosystems. Studying the Earth's core is no easy task. Since we can't directly access it, scientists rely on indirect methods like seismic wave analysis, computer modeling, and experiments that simulate core conditions. One of the most fascinating tools in this quest is the study of geoneutrinos, subatomic particles that originate from radioactive decay within the Earth. These particles provide clues about the composition and heat flow of the core. The Japanese Kamioka Observatory is one of the few places on Earth capable of detecting geoneutrinos. This underground laboratory has provided crucial data, helping scientists estimate the amount of heat produced by radioactive decay in the Earth's interior. Seismologists use natural earthquakes and artificial seismic waves generated by explosions to map the Earth's interior. By studying how these waves travel through different layers, scientists can infer the properties of the core, such as its density, temperature, and composition. The European Space Agency's SWARM mission, a fleet of satellites orbiting the Earth, is currently mapping the planet's magnetic field with unprecedented precision. This data helps scientists monitor changes in the magnetic field and predict future geomagnetic events. Some scientists believe that studying the Earth's core could unlock secrets about the formation of our planet and others in the solar system. For instance, understanding why Earth retained its molten core while Mars did not could provide clues about planetary evolution and the conditions necessary for life. The Earth's core is not just a hidden world beneath our feet. It is the driving force behind much of what makes our planet unique. From the magnetic shield that protects us to the tectonic forces that shape our continents, the core plays a crucial role in maintaining the delicate balance that allows life to thrive. As we continue to uncover its secrets, we gain not only a deeper understanding of our own world, but also of the potential for life on other planets. Thank you for joining us on this journey to the center of the Earth. If you enjoyed this video, don't forget to like, share, and subscribe to Zane Facts channel for more intriguing explorations of our incredible planet and beyond.